This is my second part of the linear dependence and independence videos, where I'll just show you more of the linear if a matrix is linearly dependent or independent. In my previous videos, I just showed you how to identify if the matrix has a linear dependence or independency with a couple of conditions to meet. But in this particular video, I'll show you how to identify if a polynomial is linearly independent or dependent. So a matrix given in the form of ax squared plus bx plus c, which is the form of polynomial equation, is dependent or independent based on following conditions. For example, like if you have been given 3x squared minus x plus 2, suppose, and you have x squared plus x minus 1 and x squared minus 3x plus 4. So these are the three polynomials given to you to identify if they are linearly dependent or independent. What you need to do, you need to form this into ax squared plus bx plus c, right, equals to 0. So take a and the equation 1, then b, let b equation 2, and c equation 3 equals to 0. Now, if you remove the bracket, you are getting 3x squared minus ax plus 2a plus bx squared plus bx minus b plus cx squared minus 3cx plus 4c equals to 0. Now, you need to separate the like terms. So, if I separate the x squared, so it gives me 3a plus b plus c, means you take 3a here, you take this b, you take this c. So that is your x squared. And then plus x, like you need to separate the b's here now. So this will give you like this, minus a plus b and minus 3c. Similarly, you just separate the numbers only, which is c, that is the rest of this, which is 2a minus b plus 4c equals to 0. Now, you take this ABC part, which gives you 3a plus b plus c equals to 0, minus a plus b minus 3c equals to 0, and 2c minus b plus 4c equals to 0. So you have the matrix. So your matrix is 3, 1, 1, minus 1, 1, minus 3, and 2, minus 1, and 4. So this is your matrix now. You need to just do the row echelon form, do reduced row echelon or only the row echelon form, and then you know if the row echelon form of the matrix has all individual values 0 means if you get x1, x2, x3 equals to 0, then it is independent. To understand more of this section, like how the row echelon form is giving you the dependent or independent, please check the part 1 videos. There I explained you with an example how to identify if a matrix is dependent or independent using the row echelon form. So as I said, you just do this row echelon form of this matrix, and then if you get individual zeros for all the ABC or x1, x2, x3, that it is dependent. But if you get a different value, for example, like if x1, x2, and x3 are not equals to 0, you get different values, then the matrix is, or the set of vectors, these three polynomials, is dependent. That's all. Thank you very much for watching it.